Study the diagram below and use it to answer the questions that follow. So we have this diagram which contains HCl, hydrogen chloride gas, that was purpled inside here. So it has H, this is HCl, and then step 1 we have HCl, the same as this, HCl, solution A. Then we have step 2, we have hydrogen ions, chloride ions, hydrogen ion, chloride ion, hydrogen ions. So the question is identify the solvent used in step 1 and step 2. So what happened? When this solution which contains hydrogen chloride went step 1, hydrogen chloride did not ionize. It just remained the way it was. It remained in the molecular form. But when it went through step 2, it decomposed. It did what we call ionization. It ionized to form hydrogen ions and chloride ions. So the question, identify the solvent used in step 1. So in step 1, because this one is a hydrogen chloride and it did not ionize here, it means this one is an organic solvent. So you just give an organic solvent like methyl benzene. So step 2, the hydrogen chloride ionized to form hydrogen and chloride ions. It means this one is a solvent like water. So step 1 is methyl benzene, or you can use an organic solvent. Step 2, water. One spatula of sodium hydrogen carbonate was poured into solution A and solution B separately. What observations were made? Explain. Effervescence occurred in solution B because hydrogen chloride gas ionizes in water to produce hydrogen ions. Remember, hydrogen ions are responsible for the acidity. So this one dissolved to formed an acidic solution. That's why sodium hydrogen carbonate reacted, producing a lot of effervescence. No effervescence was observed in solution A. There was no effervescence in solution A because here there was no ionization. There was no hydrogen ions produced because methyl benzene, hydrogen chloride dissolves in hydrogen benzene, but it does not dissociate. It does not ionize to produce hydrogen ions. So in solution A, there was no effervescence because hydrogen chloride does not ionize in organic solvents, hence no hydrogen present. The relative atomic mass of element R is 10.28. It has two isotopes, R10, so it has R510 and R511. So these are two isotopes because isotopes are elements with the same atomic number but different mass number. Hii namba hapa juu inaitwa mass number. Hii hapa chini inaitwa atomic number. Mass number is equal to the sum of protons and neutrons. So ukipewa hii, ukiulizwa proton au neutrons hapo unajua ni 5 minus 5 itakupea 5. So calculate the relative percentage of each isotope. Kwa hivyo tumepewa relative atomic mass. Sasa tunatakikana ku calculate the relative abundance. Relative abundance is always 100%. So let the 100% of this isotope yenye iko na mass ya 10 be x. So if this one is x, then that of this one will be 100 minus x because relative abundance lazima ikuwe 100%. Kwa hivyo kama ya kwanza ni x, hiyo ya pili ni 100 minus x. So RM, relative atomic mass, tunajua the formula is mass of isotope 1 times relative abundance yake plus mass of isotope 2 times relative abundance yake. Ndio maana sasa tukaweka relative atomic mass tumepewa 10.28 is equal to X, relative mass of the first isotope, that is 10, times, so relative abundance X times mass 10 plus relative abundance ya second one ni 100 minus X times mass, which is 11, divided by 100. So this is 10.28 is equal to 10X plus 110 C times in 1100 minus C times 11. After that, now hii 10 tuitoe hapa chini, you multiply both sides by 100. Hii 100 na hii ina cancel. 10.8 times 10 times 100 inakuwa 1028. Like terms together, hii kikucha pande tunatoa 11, inabaki hapa negative X. So tunapata negative 72 is equal negative X. You divide by both sides by negative 1, negative 1. The answer is 72. So X is 72. So if X is 72, then that of the second one, the percentage is 100 minus 72, which is 28. The structure shown below represents two cleansing agents A and B. We have RCOONA. It is okay to put a positive there. And R this that is B. Identify the cleansing. Remember, we have two types of soaps. Not soaps actually, but the detergents. So we have the soapy detergent and the soapless. Soapless ni kama Omo liquid soaps. Na hiyo inakuanga na benzene ring. This is called the benzene ring, and inakuanga na sulfonate group. Ukiona SO3, that one is a soapless detergent. When you see R stands for the long carbon chain, R. And this one is the carboxyl group. Therefore, this one is the soapy detergent. Soapy detergents is the same example is power soaps, like Kibuyu, Center, and that. So identify the cleansing agents. The A is a soapy detergent, B is a soapless detergent. Unajuaje? Ukiona hii ring na uone SO3, hiyo ni soapless detergent. Which cleansing agent would be more suitable for washing in water containing magnesium sulfate? Magnesium sulfate, these are the ions that contain for hard water, that makes water hard, magnesium and calcium ions. So B, that is a soapless detergent, is the suitable one using water containing these magnesium ions, because a soapless detergent does not form scum with hard water. Hard water does not affect soapless detergent, but it forms scum with soapy detergents. Work out the number of sulfate ions. Work out the number of sulfate ions in 50 centimeters cube of 1.0 molar aluminum sulfate. Avogadro's constant is this. So first we can get the number of moles in aluminum sulfate, right? But before that, we can aluminum sulfate is written as this. This is the formula for aluminum sulfate. It is important that you know. So when it ionizes, it gives 2 aluminum 3 positive plus sulfate ions. How many of them? So this is 3 of them. So the number of moles of this, we can get it from here. 1 point this molar, this is molarity. Molarity is the number of moles in 1 liter. So 1 is 1 molar. This is the number of moles in 1,000 centimeters cube. What about 50 centimeters cube? 50 times 1 divided by 1,000. Sorry, 0.005 moles. So the number of moles of this one is this. So to get the number of moles of this is twice this, because the ratio is 1 to 2 to 3. But we wanted the number of moles of sulfate ions. So the sulfate ions. So the number of moles of the sulfate ions is going to be 3 is this. So moles of the sulfate ions is going to be 3 times 0.005. Kama tuko na hizi moles na ratio ni 1 2 to 3, so kama hii ni 1 na ni 0.05, 3 itakuwa ngapi? Sino multiply, so is equal to 0.015 moles. So this is the number of moles of the sulfate ions. Lakini tunajua kwamba 1 mole of ions is equal to Avogadro's constant, which is 6.0 times 10 raised to power 23. So we can ask 0.015 moles of the sulfate ions will be how many particles, or yeah, how many of them will be there, how many ions will be there. So it is 0.015 times 6.0 times 20 raised to times 10 raised to power 23. This one will give us 9.0 times 10 raised to power 21 sulfate ions. Give the name of the following compounds. Ili upeane hii jina, kama hujaiva vizuri, kitu unafaa kufanya, make sure unafungua hii. Unaifungua how many? 1 2 3 4 5. 1 2 3 4 5. Hapa tuko na hydrogen 3. 1 2 3. Hapa hatuna. Hapa tuko na hatuna. Hapa hatuna. Hapa hatuna. Hapa tuko na moja. So tuko hapa ya 1 2 3 4 5. 1 2 3 4 5. Sawa. Hapa siko 3. Hydrogen ni 3. Ya pili hydrogen ni 1 2. Sawa. Kwa hivyo hapa hakuna kitu. So inamaanisha tunataka tukiweka double bond hapa 1 2 3 bado. So this one is supposed to be a triple bond. Kwa hivyo ukishaweka zenye umepewa, una make sure each carbon imesurroundiwa na 4 covalent bond. So that's why nimeongeza 2 hapa ndio ikuwe 1 2 3 4. 1 2 3 4. 1 2 3 4. Each carbon must be surrounded by 4 covalent bonds. So ukifanya hivyo, unajua hii sasa hii ni 1 2 3 4 5. The parent is pentyl. Then this is pentine. The parent name is the pentine, yes. But now the functional group is on carbon number 1 2. So you count for the number of carbon atoms so that you give the functional group the smallest number. Nikianza hapa 1 2 3 nitaipea 3. Nikianza hapa 1 2 ni 2. Kwa hivyo this is the correct way of labeling or numbering. So the answer is now is pent 2 ine. This one 1 2 3 4 5. So the parent name is pentane. Lakini the functional group here is OH. So that one is pentanol. So because it is an alcohol. So we want to start numbering this compound. Where do you begin giving the carbon atoms the numbering? 1 2. Hapa hivi ushajua this is an alcohol. So the functional group is OH. Una make sure hii OH imepewa the smallest number possible. 1 2. Ukianza hapa 1 2 3 utaipea 3. So the correct way of numbering is 1 2 3 4 5. Una make sure the functional group imepewa the smallest number possible. So we will have 1 2 3 4. So kwa 4 tuko na bromine. Kwa 3 tuko na methyl group. Lakini hatuwezi anza na methyl because hii lazima ikuwe alphabetical order. Ukiandika 3 methyl, 4 bromo, pentan, 2 all, uko sawa, lakini utakuwa umepata 0 kwa sababu you have not considered the alphabetical order. Sawa? So the correct way is to use alphabetical order. We will start with 4 bromo. B comes before M. So bromo, 3 methyl, pentan, 2 hii ni ya mahali the functional group iko 1 2 carbon number 2. Pentan 2 and then all. Butane and bromine reactor shown. Name the type of reaction taking place in this. So the reaction where butane, alkanes only undergo one reaction, and that chemical reaction is called substitution reaction. They don't undergo any other reactions other than substitution reactions. They undergo only substitution. And for substitution to occur, there must be a condition necessary for that substitution. Here, we must have UV light. So the condition is the UV light. Or you simply say sunlight. Sunlight. Calculate the oxidation number of sulfur in this. To calculate the oxidation number, this is an ionic compound. It has got a charge. So sorry, you have to equate to -2. So because the sulfate yenye tunatafuta iko 2, we use 2x. So 2x plus oxygen moja inakuanga -2, but there are 3. So -2 times 3 is equal to the charge. The charge is -2 is equal to the charge. So 2x minus 2 times this is -6 is equal to -2. Like terms together ikuje huku. So taongeza 2x is equal to 4. And then x itself is equal to +2. So the oxidation number for sulfur in this compound is this. What if you had a compound like sodium, this one? If you were told to find the oxidation number in this compound, this one is now a compound, it has no charge. If we wanted the oxidation number of sulfur here, you write hydrogen in 1, that is 1 times 2 plus x plus oxygen moja ni -2, there are 4 times 4 equal to 0. If it is a compound or an atom like magnesium, like aluminium, we will equate it to 0. Sawa? Hiyo ndio nilikuwa nataka ujue. So itakuwa 2 plus x minus 8. So umeona? Hii times ni -8 is equal to 0. You like terms together. This one is hii otherwise itabaki x minus 6 equal to 0. So x equal to +6. So the oxidation number of sulfur here is +6, while here it is +2. Asifanani, inategemea ni compound gani umepewa. Kama ni ion, tuna equate with the charge. Kama ni compound yenye ina ion, tuna equate to 0. Consider the following half cell reactions. These are the half cell reactions we have been given. Using the above potential values, explain whether it would be appropriate to store a solution of zinc nitrate in a container made of element Y. Element Y. Can zinc be stored there? Zinc tunajua inakuanga negative, but hapa tumepewa ikiwa positive. So you use what the potential values above. So usitumie what the knowledge unajua. Use what you have been given. To answer this question, first you calculate the EMF. Sawa? If the EMF is negative, the reaction will not occur. Sawa? If the EMF equal to positive, the reaction will occur spontaneously. The reaction will occur. Hiyo ndio kitu sasa unafanya. If the EMF is negative of zinc ions and Y, and then the reaction, if it is negative, the reaction will not occur. If it is positive, the reaction will occur. Kwa hivyo, the first thing we do is to calculate the EMF. E theta of the cell, E cell, is given by E theta reduction minus E theta oxidation. So using this one, now which one will undergo oxidation? We are considering this and this. Which one will undergo oxidation? Kwanza tumeambiwa determine whether zinc will. Kwa hivyo zinc is the one that is going to undergo oxidation hata kama iko negative. Tumeambiwa zinc, we are determining whether zinc will be stored in this element. zinc ndio inaweka kwa hii Y. So zinc will undergo oxidation. Zinc will undergo oxidation. So this one will undergo oxidation. And this one will undergo reduction. So it depends on the question given. So when a question inaulizwa. That's why it is important to understand the question. Explain whether it would be appropriate to store a solution of zinc nitrate. Kwa hivyo zinc ndio inaweka kwa hapa kwa hii container iko Y. Zinc is going to, we want to see whether zinc is going to oxidize this one or not. So E reduction, we have said it, so that is negative 0.44 minus E, which is minus 0.76. The answer is going to be negative 1.10 volts. Because the answer is negative, then you conclude that it will be appropriate since no reaction will occur. There will be no reaction which will occur. Study the scheme below and answer the question that follow. We have solid, white solid, which reacts with sulfuric acid and heating. A colorless gas is produced. A colorless gas X reacts with ammonia to form a white fume Y. A colorless liquid plus water, it forms solution Z. Solution Z heat with solid W, it forms pale blue, yellow, pale green, or yellow gas V. Write an equation for the formation of white fumes. So what forms a white fumes is the reaction between ammonia and hydrogen chloride. So the solid here should be rock salt, which is sodium chloride. Sodium chloride will react with sulfuric acid to produce hydrogen chloride gas. Hydrogen chloride will react with ammonia to form ammonium chloride, which is a white fume. What is the function of solid W in this reaction? It is used as oxidizing agent. Identify gas V. Gas V is chlorine gas from the color. You can know that one. When a current of 1.5 amperes was passed through a cell containing the charge of 3, the metal L for 15 minutes, mass of cathode increased by this. 1 Faraday is equal to this coulombs. Calculate the quantity of electricity used. The formula is quantity of electricity is equal to current I times T. Time must be always in seconds. Here we have been given time in minutes. It is your responsibility to change the time from minutes to seconds by multiplying by 60. So it is current, which is 1.5 amperes times 15 minutes times 60 to convert this one into seconds. And this one gives us 1350 coulombs. Determine the relative atomic mass of metal L, relative atomic mass RFM. But we were given that L is 3 positive, so it has a charge of 3. 1 Faraday is equal to 1 charge actually. If they have 3 charges, the charge is 3 positive, it means it has 3 Faradays. So 1 Faraday is the same as 1 charge. If the charge is 1, it has 96,500 coulombs. So what would be 3? The charge is 3, it means it is 3 Faradays. So 3 Faraday would be how much? So it is this one times this, which is this coulombs. 1 mole is equal to RFM is equal to this. But we have been given that this 1350 coulombs will produce 0.26 grams. So tunataka kujua hii ita produce ngapi, and this one will give us the RFM. So this times this divided by this, it gives us 7.756, and that is the relative atomic mass of L. Please allow me, I'm doing faster because of time. So that's why I am showing you what I have done already. I hope you will follow up. A student dissolved solid J in water and carried out the following test. He added barium nitrate to a 2 centimeters of solution and observed the formation of a white precipitate. To another portion, he added aqueous ammonia till in excess, where a white precipitate that dissolved in excess was noted. Write an ionic equation for the reaction between solution J and excess ammonia. So whenever you hear that ammonia was added until in excess, if it is ammonia, then the white precipitate dissolved to form a colorless solution. That one is always zinc, 2 ions present. So you should know that. If you are adding barium nitrate, a white precipitate is formed, then you should know the sulfate, the sulfite, or the carbonate is present. So these 3 must be present. So to write an equation, we write the zinc ions plus 2 hydroxide ions, which forms a white precipitate of zinc hydroxide. In excess, the zinc hydroxide in excess ammonia dissolves to form a complex which we call tetraamine zinc 2 ions. So this is the equation which you must master because it is a very common question. Solution J, barium. So barium plus the sulfate ions, it will form barium sulfate. Instead of this, you can use the sulfite. Instead of this, you can use the carbonate, because both of these 3 will form a white precipitate with barium nitrate. So nimechagua hiyo. You can use either this or this. A mixture of carbon 2 oxide and carbon 4 oxide and carbon 2 oxide are passed through potassium hydroxide as shown. So this is a mixture of carbon 4 oxide and carbon 2. Imepitishwa kwa potassium hydroxide solution. So there is a blue flame here which is burning with gas X. So the question is, name gas X. Which gas do you think is burning here? Is it carbon 4 or carbon 2? Is it CO or CO2? But we know that the CO2 first, it does not support combustion, so it will not burn. Therefore, again, it is passed through potassium hydroxide. This one will absorb all of the carbon 4 oxide, so it will not even go to this end. So this one will absorb all carbon 4 oxide. So the gas here is carbon 2 oxide. Write the equation of the reaction that takes place in the boiling tube. In the boiling tube, we have potassium hydroxide, which will react with carbon 4 oxide. And the reaction is going to form potassium carbonate plus water. So you need to balance the equation like this. So this is how you write the equation. Explain why calcium hydroxide is used as to confirm the presence of carbon 4 oxide and not sodium hydroxide. Sodium hydroxide or potassium hydroxide cannot be used to test for carbon 4 oxide. The reason is that the carbonate that is formed, sodium carbonate and the potassium carbonate, are soluble. They are colorless solutions, so they will not form a white precipitate. But calcium hydroxide will form a white precipitate with carbon 4 oxide. Therefore, you would see that carbon 4 oxide was bubbled through here. You would now be able to know. I have said potassium hydroxide and sodium hydroxide cannot help us to confirm the presence of carbon 4 oxide. Why? Because the reaction between sodium hydroxide and CO2, it forms a soluble salt, which is sodium carbonate or potassium carbonate, if it is this one. So that one will not form a white precipitate. Calcium hydroxide will react with carbon 4 oxide to form calcium carbonate, which is a white precipitate, while sodium hydroxide will react with CO2 to form a soluble salt, sodium carbonate, hence no white precipitate. 2 grams of sodium hydroxide is added to 30 centimeters cube of 1 molar sulfuric acid. What volume of 1 molar of 0.1 molar potassium hydroxide should the solution will be needed to neutralize the excess acid? So here, this is what we call the back titration. Sodium hydroxide is going to react with the sulfuric acid. Because the acid is in excess, again it is going to be reacted with potassium hydroxide. So allow me take you through the calculations very fast because of time. So first, lazima unajua hiyo equation venye inakuwa, lazima ujue kuandika the balanced equation of sodium hydroxide reacting with sulfuric acid to form sodium sulfate plus water. So then first tunataka kutafuta moles of sodium hydroxide. Tuko na grams, tuko na RFM from this. Sodium is 23, this one. So sodium hydroxide is 23 plus 16 plus 1, which is 40. So moles tunajua is equal to mass over RFM, which is 0.5. So moles of sodium hydroxide is 0.05. So the ratio is 2 to 1 to 1 to 1. So once we know the moles of this, we can know moles of this that reacted with this automatically. So yes. But first, since we have the molarity of this one, the molarity was 1 molar. So, and the volume that was used here is 30 centimeters. We can first get the original moles of sulfuric acid that was used. We can get the molarity of the original. Moles of original sulfuric acid is equal to 1 molar means is the number of moles in 1,000. 1 molar is the number of moles in 1,000 centimeters cube. What about 30? So originally sulfuric acid ilikuwa na 0.03. Kwa hivyo yenye react na sodium hydroxide tutaipata tukitumia hii molarity. Moles of acid that reacted with sodium hydroxide tunatumia hii ratio. Kama hii ilikuwa 0.05, 1 itakuwa nini? Itakuwa a half. Sawa? So moles of sulfuric acid 2 is equal to 2. What is equal to 0.5? What about 1? So itakuwa 0.05 times 1 divided by 2. So moles of sulfuric acid that reacted with sodium hydroxide is 0.025. So inamaanisha as moles ya sulfuric acid yenye ilibaki ni 0.03 minus 0.025 yenye react na sodium hydroxide. So yenye react na potassium hydroxide ni hii sulfuric acid, number of moles yenye ilibaki. So moles of sulfuric acid itakuwa twice kwa sababu the equation will be the same. Sasa tuko na moles of sulfuric acid, moles of sodium hydroxide, equation itakuwa kama hii. Itakuwa twice. So itakuwa ndio maana hapa ni 2 times hii moles. So this is the number of moles of sodium hydroxide. Potassium hydroxide. Lakini tunajua molarity ya potassium hydroxide ilikuwa 0.1 molar. Sawa? In 1,000 iko hii. So in 0.1 is equal to 1,000. So tutauliza this moles of potassium hydroxide itakuwa ngapi? So itatupea 100, and that is the volume of potassium hydroxide which will react with excess acid. The setup below shows the catalytic oxidation of ammonia in the laboratory. This is the hot platinum. This is ammonia inside here. State and explain the observation made. Write the chemical equation for the first reaction taking place in the beaker. Then, yes. So, state and explain the observation. Production, there will be a production of brown fumes. That is the first observation. Or you can say platinum rod grows red. Yeah, it grows red. The reason why it is going to grow red, it is because the reaction between ammonia and oxygen is exothermic. It produces a lot of heat. Therefore, heat produced makes platinum to grow. Brown fumes are formed due to the oxidation of nitrogen 2 to nitrogen 4, which is brown. So when ammonia is reacting this way, it produces nitrogen 2. Nitrogen 2 on coming up here, it finds oxygen and then it oxidizes the nitrogen 2 which is colorless to nitrogen 4 which is brown. That's why the brown fumes are observed. So write the chemical equation. So ammonia reacting with oxygen, it forms nitrogen 2. The nitrogen 2 are then oxidized by oxygen in the air to form nitrogen 4. So this is the first equation which takes place before the nitrogen 2 is oxidized. So this is the equation which you are supposed to know how to write. Write the chemical equation representing the thermal decomposition of the nitrate of the following. Remember, the nitrate of potassium and the sodium is different from the others. When potassium nitrate or sodium nitrate are heated, they produce the potassium nitrite plus oxygen, nitrite. Others like copper nitrate, lead nitrate, it will produce the oxide, the nitrogen 4 and oxygen. But silver and mercury will also behave differently. So silver will give you silver metal, nitrogen 4 and oxygen. So it is important for you to note those differences when nitrates are being heated. So in summary, most reactive metals, when the nitrates of most reactive metals, they produce the nitrites plus oxygen, that is sodium and the potassium. The middle metals like copper, zinc nitrate, copper nitrate, lead nitrate, when heated, they form the metal oxide, nitrogen 4 or oxide, then oxygen. Those metals that are less reactive like silver and mercury towards the end, because they are the least reactive the metals here, they produce their metal, nitrogen 4 and oxygen. Using an energy cycle diagram, calculate the standard enthalpy change of formation of carbon disulfide. So carbon disulfide is CS2. This is called carbon disulfide. So first, you need to know how to write the equation of carbon plus sulfur to form this one. So to draw an energy diagram, level diagram, you need to have some knowledge on how sulfur is going to combine with carbon to give you carbon disulfide. So that is the first reaction, formation of calcium. This one, sulfur plus oxygen, that one we will have been given sulfur plus oxygen, it will give us sulfur 4. But carbon disulfide, when heated, plus oxygen, how many oxygens here? 3, it gives us this, right? It gives us carbon 4 plus sulfur 4. That one you have been given. So kitu ulikuwa unafaa kujua ni hii equation. Ukijua hii, hizi zingine zote umepewa. Hii carbon disulfide plus oxygen is equal this, ndio hii. So this one is the most important thing ulikuwa unafaa ujue kwanza. But we know from the Hess law of constant heat summation, we know this one is the direct, this is the indirect route of getting this, and this one is the direct route. This and this is the direct route, and this one is the indirect route. But the Hess law states that the energy changes that in converting reactants into products is the same regardless the route. Whether I use this wrong route or this short, the direct route, the chemical change, regardless of the route by which the chemical change occurs, the energy is going to be the same. So this one, the direct route is equal to indirect route. So that's why we have done like this. This one plus this one, I gave this one H1, H2. H1 plus H2 will be equal to this delta H of formation plus delta 3H, H3. So hii tulikuwa tumepewa negative 339.93. So negative 393 plus hii moles ni 2, ndio maana nimepiga times 2. From here to here is negative 294. Negative 294 times 2 kwa sababu the number of moles. Hii ni per mole, 1 mole, but these are 2 moles. Times 2 is equal to, we are looking for this one is equal plus, this is negative. We have been given that. So hii ukimtoa utapata negative 981 is equal to delta HF minus this. You like terms together. So inakuwa hivi, and then you find the heat. The standard enthalpy change for formation of carbon diosulfate is positive 91 kilojoules per mole. An element has an atomic radius of 0.136 millimeters and an ionic radius of 0.065 meters. Is this element a metal or an nonmetal? Give a reason. Kwa sababu ukiangalia atomic radius is bigger than the ionic radius, or the ionic radius is smaller than the atomic radius, automatically that one is a metal. The element is a metal. It loses electrons to form an ion, hence stronger nuclear attraction to the remaining electrons. So as the outermost energy levels electron is removed, the nuclear attraction becomes stronger. Then it boosts the outermost energy, the remaining outermost energy, the outermost electrons that are remaining even more, making the radius small, the ionic radius small. So the element is a metal. It loses electrons to form an ion. A radioactive element weighs 384 grams. After 270 days, its mass fell or reduced to 48. Calculate the half-life of the element. A half-life. First, you should know what is a half-life. A half-life, it is the time taken for a radioactive isotope to decay or to disintegrate to a half its original mass. So that time that it takes to decay to a half its original mass is called the half-life. We can calculate a half-life using the formula or using the concept. First, the formula is that the remaining amount is equal to a half raised to power n times original mass, where n is the half-lives. Kwa hii hesabu tunatafuta half-life, so hatuna n, we are looking for n. Remaining amount ndio hii 48. Original amount ndio hii 384. So 48 is equal to a half raised to power this like that. We remove this here, divide by both sides by 3. Tunapata hivi. So hiyo ukidivide by itakupea hii. Raised to this. Tunataka n, we can use the logs. So you introduce logs, inakuwa log 0.125 is equal to n log 0.5. When you divide by that, you find that n is equal to 3. So we have 3 half-lives. So if the total time it takes is 270, 1 half-life is, so 3 half-lives is equal to 270. 1 half-life will be what? So it will be 90 days. So 1 half-life is 90 days. If that is difficult, you can use the general understanding. Original mass ilikuwa 384. So the half-life ni the time taken for the mass to reduce to its original, yani a half original. Kwa hivyo 382 a half ni nini? Ni 192. Kwa hivyo hii hapa kutoka hii time kutoka hapa mpaka reduce mpaka hapa ndio inaitwa a half life. So ikatoka hapa ikafika hapa. Kutoka hapa ikafika hapa mpaka mwisho ikafika 48 because mwisho ilifika 48. So tunataka kuona a half lives ngapi zilikuwa hapo, ni 1, 2, 3 mpaka ikafika hapo. So there are 3 half lives. 3 half lives is equal to 270 days. 1 half life itakuwa ngapi? Itakuwa 90 what? Days. So you can use it, the formula or the knowledge. The setup below represents the apparatus used for electrolysis of magnesium sulfide. which element is the cathode? Write the equation for the reaction at the anode. Kwa hivyo hapa sasa tuchapewa ile inakuanga hivi, ndio tuchague tujue cathode ni gani, positive inakuanga hii mrefu, negative hii. Sasa hatuna, tutajuaje? Kwanza kuna vitu vidogo unafaa kuelewa kwa electrolysis. Sawa? First, magnesium sulfate iko na how many ions? Iko na 4 ions in it. Iko na magnesium 2 positive, iko na hydrogen ion from water, iko na hydroxide ion from water, na iko na sulfate from magnesium sulfate. Those that are negatively charged inakuwa attracted towards the positive. Those that are positively charged they are go to the negative. So the negative is the cathode. The positive is the anode. So this one will migrate to the anode. This one will migrate to the cathode. So hiyo ndio kitu tunafaa kujua. Alafu this one is going to produce hydrogen gas and oxygen. So hydroxide ions are discharged at the anode, and in the presence of that one they give us oxygen. Hydrogen ions are discharged at the cathode to give us hydrogen gas. But hydrogen gas inatokanga ni 2 moles. So the ratio of oxygen to hydrogen inakuanga ni 1 to 2. So ukiangalia hii diagram, hii space ya gas yenye ilikuwa formed hapa ni kubwa, hii ni ndogo. Automatically hii inakuambia ni hydrogen gas, hii inakuambia ni oxygen. Kwa hivyo kama oxygen ilikuja hapa, hii ni nini? Hii ni cathode, hii ni anode, hii ni cathode. So which element is the cathode? The element Z. Z is the cathode. So write the equation for the reaction at the anode. At the anode hydroxide ions are going to be discharged to form oxygen. So hydroxide ions are going to be discharged to form water plus oxygen plus 4 electrons. So this is the equation at the. I hope umeona kenye nimefanya. A bicycle was found to hold a maximum volume of 990 centimeters at STP. On one more hot sunny day, the temperature was 30 degrees and the pressure this. The rider inflated the tire. Explain what happened. Show your calculations. Standard temperature and the pressure. So at STP, the temperature is 0, which is the same as 273 Kelvin, and the pressure is that. So we use the formula. So kwanza unafaa kujua at STP, this is the pressure, and the temperature is 0 degrees. 0 degrees is the same as 273 Kelvin, because here we don't use temperature in degrees, we use temperature in so pressure 1 times volume 1 divided by T1 will be temperature 1 will be equal to pressure 2 volume 2 over this. So for us to comment what happened, kwanza lazima calculate the volume. Sawa? So pressure 1 is 760 times volume 1 99 this divided by temperature 1. Temperature 1 is 273, which is 0 degrees. Volume 2 is what we are looking for. Temperature 2, sorry, we have the atmospheric pressure 2 is 800, and then temperature 2 is 30. 30 you add 273, because 273 is the Kelvin, we don't use the degrees. So that's why 303. So you find that the volume 2 is going to be this. So the volume 2 is 1043 centimeters cube. So what will happen kama ina occupy 990 na saa hii imefika 1043? What will happen? It will burst. So hivyo ndio unajua what will happen. So the tire will burst since the volume of air exceeds its maximum capacity. Consider the equation here. We have hydrogen peroxide with water. It is at equilibrium with this. State and explain the species acting as a base in the backward reaction. A base, remember, a base is the proton acceptor. So, while an acid is a proton donor, according to whose definition? So, this one will accept the proton from this one. So this one is going to act as an acid, and this one is going to be a base. So state and explain species acting as a base. So it is this one because it is going to accept a proton from hydroxonium ion to form hydrogen peroxide. That in terms of structure and bonding, explain why the melting point of silicon 4 oxide is such higher than that of sulfur 4 oxide. So silicon 4 oxide has a giant atomic structure with strong covalent bonds. So while sulfur 4 oxide has molecular structure with weak van der Waals forces. That's why the melting point of this one differs a lot. This one is very high and this one is very low because of that. A compound Q with molecular mass this 28 contains this and this carbon, this hydrogen. Determine the molecular formula. So to determine the molecular formula, first we have to get the empirical formula. To get the empirical formula, you write element, carbon, hydrogen, mass in percentage, 85.7 for carbon, 14.3 for hydrogen. RAM tumepewa 12.1. Number of moles is mass over RAM. 85.7 divided by 12 is 7.142. 14.3 divided by 1 is 14.3. Mole ratio tuna divide by ile ndogo. The number of moles is ile ndogo. So ndogo kabisa ni 7.14. So 7.14 divided by 7.14 is 1. 14.3 divided by 7.14, the answer is 2. So the empirical is C1H2. So H2. And then now the molecular formula, we get it that the empirical formula times N is equal to 28. This C in 12, hydrogen in 2, 1 plus 1. So for N is equal to 2. And then now our molecular formula is this. Write the structure of the Q. So Q ukiangalia ni carbon ni mbili, unaweka carbon 2. So here you just write carbon, carbon. Hydrogen ngapi? 1. Here hydrogen, here hydrogen. So ukiangalia hii carbon haijazungukwa na 4 covalent bond 1 2 3 1 2 3. So ni jukumu lako sasa kujua, unaongeza moja ndio ikuwe sasa this one is within. The following setup was used to investigate the condition necessary for rusting of iron. After several days, it was found that the nails did not rust. Identify solid B. So if there was a solid B here, it must have absorbed all the moisture from there, and that one is anhydrous calcium chloride because it is a drying what? Agent. The following are the standard electrode potentials of some cell reactions. Use the data to answer the question 34, so you can look at the table like that. So suggest the identity of U. U is 0. Ni gani ile nakuanga na 0? Ni hydrogen. So that one is hydrogen. Draw a label diagram for an electrochemical cell that would produce the largest EMF. The largest EMF will be produced by the most negative and the most positive. The most negative and the most positive will produce the largest EMF. So tunaenda kuunganisha S na W. So and this is the diagram for S and W. So S unaweka 1 molar solution S, and this one will be electrode S. This is the salt bridge. Don't forget to label salt bridge. This one is going to be W. So electrons will move from, this one is going to be, this one will undergo oxidation. So electrons will move this way, because this one is more reactive than this. So this one will undergo oxidation, this one will undergo reduction. Study the diagram. So you can see we have this sodium na 10 waters, sodium 1 water. Give the UPAC name of the compound A. This one is sodium 10, inaitwa decahydrate. So sodium carbonate decahydrate. That is the UPAC name. Deca, it is for the 10 waters. If it is this one, is called sodium monohydrate. Sawa sawa. Kama iko na 5 hapa, inaitwa sodium pentahydrate. So this one is decahydrate. Give the name of the process. Which process is this? Where a substance loses water of crystallization to the atmosphere. That one is called efflorescence. Efflorescence process. Write an equation to show the compound when compound B is heated in a boiling tube. So this one, if it is heated, it loses water of crystallization to form this one as a solid, water, and this one is also a solid. Below is the equation of a reaction that takes place in a catalytic chamber on the upper process. Ammonia reacting nitrogen plus hydrogen to form ammonia, the equilibrium. Explain how the yield of ammonia will be affected if the pressure is increased. Increasing pressure will favor the forward reaction, where we have fewer of the, this is 1 plus 1, 1 plus 3 is 4. So here the volume is 4, here volume is 2. Increasing pressure will favor the direction where we have fewer molecules. So increase in pressure leads to increase the yield of ammonia, since increase in pressure will favor the direction with fewer molecules. Therefore, equilibrium will shift to the right. Given lead 2 oxide, nitric 5 acid, sodium carbonate solid, and water, explain briefly how you can prepare lead 2 carbonate. So you react lead 2 oxide with nitric acid to form lead 2 nitrate. Dissolve sodium carbonate in water to form a solution of sodium carbonate. Mix lead nitrate and sodium carbonate solutions to obtain lead carbonate solid. Filter the mixture to obtain lead carbonate as the residue. Dry the residue between filter papers. The diagram is also about the preparation of oxygen. Oxygen, we have 2 ways of preparing. When we use water, here we must have sodium peroxide. When you see here, it is hydrogen peroxide. If you see hydrogen peroxide here we have potassium, we have manganese 4 oxide, which is the catalyst. Write the equation. This is sodium peroxide plus water. It gives you sodium hydroxide plus oxygen. Commercial uses of oxygen: used in hospitals by patients with breathing difficulties or problems. Used to remove impurities in steel making. Liquid oxygen is used as a rocket fuel. What will be observed when chlorine is coupled through potassium bromide? Explain using chemical. The solution changes from colorless to brown because bromine is brown. So chlorine will displace bromine from its solution because it is more reactive than bromine. And this is the equation. Welcome. We want to look at how to know the products formed during a chemical reaction. How do you tell which products are formed during a chemical reaction? So there are things you must know for you to write the correct products that are formed during a chemical reaction. Remember, for a reaction to occur, there must be a reactant, two reactants which are combining to form a product. Right? So reactants are always written on the left side. This is the left, and after the arrow is called the right. So the reactants are written on the left side of the equation, and the products are written on the right side of the equation. So for you to know what products are formed, there is this information which you must know. Generally, you should know the following. Number one, you know metals, non-metals. By the way, how do you know that an element is a metal and another one is a non-metal? I have already said that there's a video for that. You can check it. So for now, you should know that a metal, generally that a metal plus an acid, you should know the names of the acids. We have hydrochloric acid, nitric acid, sulfuric acid. So when a metal reacts with an acid, what do they form? You should know that a metal plus an acid, the answer is the metal salt plus hydrogen gas. So for example, when I give you zinc plus sulfuric acid, it forms zinc sulfate, zinc sulfate, zinc sulfate. You can see it is the metal salt. The salt comes from the acid, and then plus hydrogen gas, right? Number two, metal plus steam. Steam is water but in vapor form. So what does it form? A metal plus a steam, you should know that it forms the metal oxide plus hydrogen gas, right? For example, magnesium plus steam we write it in gaseous form. It will form magnesium oxide plus hydrogen. So when you know that this general information, it becomes very easier for you to write the products. Number three, metal plus water. What do they form? A metal, any metal, if a metal that is able to react with water, it will give you the metal hydroxide. Metal hydroxide plus hydrogen gas. Very important. An example is magnesium plus water. Now this water is a liquid form, solid. This one will give you magnesium hydroxide plus hydrogen gas. The equation will need to be balanced, so we are not talking about the balancing, but that's how the equation will be. But we have to put 2 here to balance the equation, as simple as that. Number 4, metal plus oxygen. A metal plus oxygen, we just get the metal oxide. Metal oxide. For example, sodium plus oxygen. This one is a gas, this one is a solid. What does it form? It forms sodium oxide. Simple as that. It forms sodium oxide. So if you know that a metal plus oxygen, it gives you this, then you won't go wrong. You will not go wrong. Number 5, you should know that an acid plus metal carbonates. A metal carbonate is an example is zinc carbonate, sodium carbonate, magnesium carbonate. That's what we call metal carbonate, because you see I'm putting a metal and then the carbonate. magnesium carbonate, aluminium carbonate, although we don't have that. So what does it give you? So if it is an acid, any acid that is reacting with a metal carbonate, you should expect the metal salt. You should expect carbon dioxide. Allow me to write in the carbon dioxide and then plus water. So an acid plus a metal carbonate, it gives you the metal salt, carbon dioxide plus water. For example, acid, let me use HCl plus zinc carbonate. It will form zinc chloride because the chloride will come from here. It will form zinc chloride plus CO2 plus water. So as you can see, this one is permanent. Any carbonate with an acid will form this. The only difference will be on the salt side. So we will put 2 here to balance the equation. Number 6, an acid plus a base. First, I realize very many people do not know what are bases. We have 2 types of bases. Let me describe them here so shortly. Base, we have 2 types: metal oxides and metal hydroxides are bases. For example, here zinc oxide, magnesium oxide, these are the bases. They are called the bases. Sodium hydroxide, potassium hydroxide, these are the bases. So whenever you see an hydroxide reacting with an acid, whenever you see a metal oxide reacting with an acid, that one is a base. So an acid plus a base will give you the salt, metal salt, plus simply water. For example, magnesium oxide plus nitric acid, H2, nitric acid is HNO3. It forms the metal salt. The metal is magnesium, you write magnesium. The salt comes from the nitric acid, so magnesium nitrate plus water. As simple as that. So you see, this general information is very, very important for you to write correct chemical equations, correct chemical formulas, and then balance the equation. Number 7. Reactions that form in soluble salts. So those reactions that form in soluble salt, you should know how the products are. For example, I'm going to give an example: sodium carbonate plus magnesium chloride. This reaction, now sodium carbonate is reacting with magnesium. This is a double decomposition reaction or a precipitation reaction. Therefore, they will change the cations and the anions. So the cation this side will take the anion this side. The cation this side will take the anion this side. So this one is going to form magnesium carbonate plus sodium chloride. Then we will put 2 here to balance the equation. This one is a solid, aqueous. So this is how it's going to react. But if you have a problem here, I have done a video on salts, how to prepare insoluble salts. It is in the description. You would check the link and go and look at it. So there is a complete video for insoluble salts, reactions, all of those. I think up to that point, I want to thank you for your time. Number 8, effect of heat on nitrates. In short, we are saying, what are the products formed when nitrates are being heated? Here we have 3 scenarios. We have 3 scenarios where nitrates of the most reactive metals, when they are heated, they give different compounds. Like nitrates of potassium nitrate and sodium nitrate. When they are heated, they give potassium nitrate plus oxygen. The similar here, sodium nitrate plus oxygen, right? You can balance the equation like that. So you should know that nitrates of the most reactive metals, they decompose on heating to form the corresponding nitrite plus oxygen. The rest, except those of silver, Ag, mercury, decompose to give the oxide, nitrogen 4 and oxygen. So this is what I'm saying. Now those that are in the reactivity, the middle of the reactivity series, such as copper nitrate, zinc nitrate, all of those, they decompose. The rest, let me write that the rest except silver nitrate and mercury nitrate, decompose giving, so let me say giving what? Giving the metal oxide plus nitrogen 4 plus oxygen. For example, if it is zinc nitrate, when you heat zinc nitrate, it will give you zinc oxide plus nitrogen 4 plus oxygen. All of them will behave like this except potassium nitrate, sodium nitrate, and silver nitrate, mercury nitrate. The rest will behave like this. If it is copper nitrate, it will give you copper 2 oxide, nitrogen 4 plus oxygen. So what happens to silver and mercury? So silver, Ag nitrate, decompose on heating to give you silver itself plus nitrogen 4 plus oxygen. That is the difference. Mercury will decompose when heated to give you mercury itself plus nitrogen 4 plus oxygen. So you can see the scenarios I was talking about, that for silver nitrate, mercury nitrate has a valence of 2, you should know that. Silver is valence 1. It gives a metal. Silver will give you silver, which is a metal. Unlike the ones that are in the middle, the most reactive and those that are least reactive down there, they behave differently. So those are the things you must put in mind for you to score a lot of marks in chemistry, paper 1 and paper 2. Another important thing you should note is the colors of the oxides. You should know that copper 2 oxide is black, zinc oxide is white when cold, and yellow when hot. So those things you should also know them, because they are very, very important in helping you to unravel some kind of questions being asked. Number 9, effect of heat on carbonates. In other words, we are saying, what are the products formed when carbonates are being heated? When you heat a carbonate, what are the products formed? First, you should know that carbonates of potassium, carbonates of sodium, they do not decompose. So sodium carbonate, potassium carbonate, they don't decompose. Don't decompose when heated, because when they are pure, they cannot decompose. But the rest of the metal carbonates decompose when heated to form this. So let me generally write that metal carbonate. When you heat a metal carbonate, it decomposes to give you the metal oxide plus carbon 4 oxide, as simple as that. For example, you can take zinc carbonate. It will decompose to give you zinc oxide plus CO2, as simple as that. So all carbonates will decompose to give you the metal oxide plus carbon 4 oxide, except potassium carbonate and sodium carbonate, because they do not decompose on heating. Other reactions that you must also know is the reducing agents. When hydrogen is reacting with the copper 2 oxide, what happens? So those are some other reactions that you must know. For today, I want to reach it there. If you have any question, you can comment, you can contact. My contacts are on the description. Thank you.